Hello friends, today we see the second last article from the chapter Mathematical Methods. The article is Introduction to Calculus. Okay, this is the most important article. As per exam view, there is no any question related to the calculus, but to understand the mathematical steps, to solve the numericals, to solve the proof of theorem, we require this calculus part widely. Now, calculus means what? Then it is very easy. Calculus is a branch of mathematics. Calculus is a branch of mathematics which was introduced by scientist Newton. In a calculus, there are two types. One is differential calculus, and second one is the integral or integration calculus. What is mean by the differential calculus? What is mean by that integral calculus? All the terms that we have to study in this article. First of all, see what is the meaning of calculus. Meaning of calculus is very simple. There are number of mathematical quantities. That quantities are depend on other mathematical quantities. Just see the one example. As the time increases, we start a one vehicle. As the time increases, the speed of vehicle is goes on increases up to a particular time instant. Means the speed of that vehicle totally depends on the time, because time increases, speed increases up to a certain instant, up to a 5 minute, up to a 10 minute. As time increases, speed increases. Means here speed is totally depend on what? Totally depend on the time, or simply the speed is a function of time. Here the speed changes, there is a change in mathematical quantity. Here the mathematical quantity is a speed. Okay, the changes in mathematical quantity are studied in one branch. That branch is called as the calculus. Okay, see the simple meaning. Calculus is a branch of mathematics where we study the changes in mathematical quantities. Okay, calculus is a branch of mathematics where we study the changes in mathematical quantities. That mathematical quantities are depend on other physical quantities. Out of that calculus, the first part we see, that is a differential calculus. That there are the two physical quantities along the x and y axis. Let this is my x axis and this is my y axis. As the value on x axis increases, the value on y axis also increases. So nature of graph, it will be looks like this. This is a curved nature is shown. Okay. Now this is a 0. On y axis this value is also 0. This is the first point. Let it is a x1. This is the second point on x axis x2. This value is y1. This value is y2, and this difference is delta y. This difference is delta x. That is x2 minus x1 is delta x. y2 minus y1 is delta y. The coordinates of this point, when you write the coordinates, always start from the x-axis. That are x1, y1 and x2, y2. Now, just see. If I want to calculate the slope of this, then how you calculate the slope? Slope is given by simply y2 minus y1 divided by x2 minus x1. What is the y2 minus y1? y2 minus y1 is nothing but my delta y. And what is the x2 minus x1? x2 minus x1, that is nothing but my delta x. Now here, when you calculate the slope, let along this x-axis, it makes an angle theta, then slope equals to opposite divided by adjacent side, opposite divided by adjacent, because y-axis is also, this line is also parallel to y-axis. So opposite side divided by adjacent side. So this slope is nothing but one trigonometric function, that is a tan of theta, equals to y2 minus y1 upon x2 minus x1, or delta y divided by delta x. So it is very simple. Slope is nothing but tan of theta. In number of examples, we require what is the value of slope, and to calculate the value of slope, we not require the formula y2 minus y1 upon x2 minus x1 or delta y by delta x. We simply require the formula slope is calculated by tan of theta. Okay? Remember that the slope is nothing but tan of theta for this particular case. So I am writing only tan theta equals to y2 minus y1 upon x2 minus x1 equals to delta y by delta x. Instead of that, I am writing tan of theta equals to delta y divided by delta x. Let just be play with this graph. Now, as this delta x becomes smaller, 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 when this delta x becomes smaller, as this delta x becomes smaller, delta x becomes smaller means what? First of all, we know the meaning of delta x. Delta x means x2 minus x1, not x1 minus x2, because delta x is a change, and change is always final minus initial. This is my final and this is my initial. So delta x equals to x2 minus x1. Now when this delta x becomes smaller, when this x2 becomes smaller, okay? As this x2 becomes smaller, 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 let me see, x2 becomes smaller. Now this x2 comes to this part. This is my new position of the x2. At the same time, y2 is also smaller. Are you getting this? As x2 becomes smaller, or x2 move towards its origin, y2 is also move towards the origin. Okay? Therefore, as the x2 becomes smaller, this initial delta x is this much, and now delta x becomes a very small. So as delta x becomes smaller, delta y is also smaller. Are you getting this or not? Just see once again. As x2 becomes, or as delta x becomes smaller, as delta x becomes smaller, means this is my value of delta x. Okay. This delta x becomes smaller, means x2 shift towards the origin, means this length, this difference x2 becomes a smaller. Therefore, as a delta x becomes smaller, its corresponding means this y2 is also move towards the origin, and y2 minus y1 means my delta y. So delta y is also becomes a smaller. Suppose one stage will become x2 overlap on x1. x2 overlap on x1. Then what happens? Then delta x becomes x2 minus x1. This is my delta x. x2 overlap on x1 means x2 takes the value of x1. At that time, delta x becomes a 0. Delta y also becomes a 0. Okay, so these are the two important cases. As delta x becomes smaller, delta y is also a smaller. Delta x becomes a smaller means x2 move towards the origin, or x2 is on origin. No, x2 move towards this origin, and we explain or we write same thing mathematically in a different way in terms of limits. What is that value? How you write that? That we have to see first. In terms of limit, same thing is written. That is limit delta x tends to 0. Limit delta x tends to 0. Delta y divided by delta x. Here I am calculating the slope delta y by delta x. Same thing is delta y by delta x. But when the delta x tends to 0, read this, delta x tends to 0. Okay, not tends to 0 means approaches towards 0, very close to 0, moving towards 0, but not exactly 0. Remember that. Not exactly 0. Parallel word समझो. The mass of one gas molecule is negligible. Negligible means how much? Negligible means it is a 0. No, it is nearly equals to 0. Means not a 0. It is a 0.0000000 in this point. Last there is a 1 digit, non-zero digit in this way. Here delta x tends to 0, delta x approaches the 0. That is explained in terms of limits, and we can explain the same thing in this way. That is delta x tends to 0, delta y by delta x. This is equals to limit delta x tends to 0. Delta y means what? y2. y2 means what? y1 plus delta y minus of y1 divided by x1 plus delta x minus of x2. Or simply we can write y2 minus y1. But what is a y2? y2 means y1 plus delta y. x2 means x1 plus delta x. Same thing is written. Okay? Not a difficult. And this part is explained in terms of differentiation. In terms of differentiation. What is that part? What is the differentiation? How you calculate the differentiation? That we have to see first. Okay? This part is called as the differentiation. Delta y by delta x, or simply it is called as the dy by dx equals to limit delta x tends to 0, y1 plus delta y minus of y1, this divided by x1 plus delta x minus of x2. So delta y by dy by dx equals to limit delta x tends to 0, y2 minus y1 divided by x2 minus x1. But when we are using limit, when this delta x is approaches the 0, tends to 0. There are some properties of differentiation which are explained in the book, explained in the textbook. Just I am writing that properties. See that properties. Listen very carefully that properties which are most important. That is the properties of differentiation. Properties of differentiation. That properties are very simple. Let the dy dx of any one physical quantity s into function of x or anything that just I follow the textbook, f of x. If s is my constant, then we never take the differentiation of s. So s equal as it is property equals d by dx of function of x. Secondly, in a differentiation, there is a product, there is a multiplication, addition, subtraction, all are allowed. So that we have to see one by one. So d by dx of f1 of x plus f2 of x equals to d by dx of f1 of x plus d by dx of f2 of x. Means we can split that differentiation. Now the third property, if there is a product, that is very important because number of examples are there. The third property, d by dx of is equals to f1 of x into f2 of x. Then how you write this? Okay. In 12th standard mathematics or in 11th standard mathematics, we study the same thing as a UV rule. UV rule, alphabet UV rule. How this? If first thing is a constant, that is f1 of x, and take the differentiation of second. And secondly, second term kept constant, and take the differentiation of first. That is f1 of x equals to differentiation of second plus second term kept constant. Here just we s as make constant in the same way here. And the last rule, that is a fourth rule, that is if there is a division is there, then how you calculate that? That we have to also see d by dx of f1 of x divided by f2 of x. Then how you see? Then the second term kept constant, take a differentiation of first. Second term is the 1 of f2x into differentiation of first term, that is f1 of x, minus, if there is a division, then there is a minus, 1 upon first term kept constant and differentiation of the second. That is the fourth property, and we can multiply, for example, d by dx of f of x. We can write the same thing in this way. What we are doing here, just we are multiply and divide. Just we are multiply and divide. So these two terms are get cancelled and we are getting the original term as it is. So there is also no change. Such a type of rules are there to calculate the differentiation. On the next page of the textbook, again there are some rules are given. Just take a one screenshot, and I am writing that 9 rules. But one by one, you have to solve also the numericals. So you can easily solve the homework of this part. The first rule of derivative, d by dx of x raised to n equals to n into x raised to n minus 1. I am taking one example. d by dx of x3. How do you solve this? Here n is 3. Okay? N is my 3. So I am writing in this way. 3 as it is into x raised to n minus 1 means 3 minus 1. So term becomes 3 into x square. See one more example. d by dx of x raised to 9. Now how you solve this? Compare with the standard rule. Okay, d by dx of x raised to n equals to n into x raised to n minus 1. The same way, d by dx of x raised to n, here 9 is my n, so 9 as it is into x as it is, x raised to n minus 1, so it becomes a 9 minus 1, so it becomes a 9 into x raised to 8. Simply, suppose the term is like this, d by dx of x raised to minus 1, then how you solve this? Compare with this. Here n is my minus 5, so minus 5 as it is into x raised to n minus 1, so minus 5 minus 1, so answer becomes minus 5 into x raised to minus 6. Okay, this is my final answer. This is the first rule of differentiation. d by dx of x raised to n equals to n into x raised to n minus 1. d by dx of x raised to n equals to n into x raised to n minus 1. तुम्ही हवे तेवढे नंबर्स अरे इन्फिनिटी पर्यंत नंबर घ्या आणि सॉल्व्ह करून प्रॅक्टिस करून टाका. नॉट नेसेसरी टू रिसाइड द फॉर्म्युले. बाय सॉल्विंग नंबर ऑफ examples easily we recite the formula. Now the next is the d by dx of e raised to x. The answer is very simple, equals to e raised to x. This is the simplest formula. E raised to x, what is a e? E is my exponential. Okay, e is my exponential. When you take the log table or when we study logarithm in mathematics, then we know this term e raised to. What is the e? E stands for the exponential. And with that there is one more rule. d by dx of e raised to ax equals to a as it is into e raised to x. Okay, e raised to ax. This is the next. Very rarely we are using this. Now the third is most important. d by dx of, in book it is given in this way. That is the ln x. ln x equals to 1 upon x. Okay. What is this ln x? This is same. d by dx of log of x equals to 1 upon x. Log is expressed as a ln. Okay, so don't afraid about this. Now the fourth is about the trigonometric function. d by dx of sin x, it is a cos of x. Then a fifth, d by dx of cos of x equals to minus of sin x. Then sixth, d by dx of tan x, it is a sec square x. Okay. Then d by dx of cot x, cot its derivative is a minus cosec square x. d by dx of sec x equals to sec x into tan x. Book मध्ये मेंशन केले tan x into sec x. No matter. And the last one. Okay. We the slightly adjust होतो. Last one. d by dx of cosec x equals to minus cosec x into cot x. These are the rules for the differentiation. Okay. Now how you remember this? Just when you observe the rules of the trigonometric function, concentrate the three rules. Fifth one, seventh one, and the ninth one. All are start from the CCC, cos x, cot x, and cosec x. Their derivatives, their differentiation starts with the minus. Okay, this is very important. Remember all the terms, remember all the rules for differentiation. Then I provide you one homework. We can easily solve that homework, and afterwards we can discuss that homework.